force that drives the rotation of the wheels, the power in a mechanical clock, is provided by either weights or a mainspring. When the movement is weight-driven, the weight hangs from a cord or cable wound around a drum on the winding arbor. When the movement is spring-driven, like ours, the spring is directly connected to the winding arbor on one end, with the other end connected to the clock frame. The mainspring assembly is made up of the winding arbor, mainspring, great wheel, ratchet wheel, click, and click spring. The purpose of all these parts is to make a one-way device so that under normal conditions the mainspring will provide power to the wheel train, but will also allow the winding arbor to be turned in the opposite direction to wind the spring without disturbing the wheel train. The winding arbor has a square section to accept the winding key, and a pin or hook to catch a hole in the inner end of the mainspring. The spring pulls on the hook of the winding arbor, causing the arbor to rotate as the spring unwinds. Attached to the winding arbor is a ratchet wheel that turns with the arbor. Slipped over the winding arbor is the great wheel, which rests up against the ratchet wheel. The great wheel is a slip fit and is free to rotate. Without some way to prevent it, the great wheel will spin freely on the winding arbor and will not transfer power from the mainspring to the wheel train. This is where the click comes in. The click is riveted to the great wheel so that it will engage the ratchet wheel. The click is forced into the teeth of the ratchet wheel by the click spring. Since the ratchet wheel is forced to turn with the arbor, when the click is engaged in the ratchet wheel, the click forces the great wheel to turn with it, transferring power from the mainspring to the wheel train. We wind the mainspring by turning the winding arbor in the opposite direction of its normal rotation. This causes the click to slip over the ratchet wheel teeth, making the distinctive clicking sound as the click is alternately lifted and dropped into the ratchet teeth. During winding, the great wheel is held in place by the rest of the wheel train as the winding arbor rotates backwards to wind the spring. When we release the winding key, the click is forced back into the closest ratchet tooth, and power is once again applied to the great wheel and the wheel train.